Okay. I think a few attendees had issues with audio, but that has been resolved. So good afternoon. Welcome to Friday office hours. My name is Sam Stewart. I work at the Data and Research Center in the Research Support Corps. Today we have a wonderful speaker with us today who also works with research support team, and we are going to be focusing on Fitbit data in the All of Us research program. This is recorded and will be posted to the User Support Hub in the coming week or two. I do kindly ask that if you do have questions, still hold them till the end, or you can post them in the chat, and myself or one of my colleagues will be able to answer it. So I do want to introduce our speaker. For those of you who have been coming to office hours for a while, you might recognize Aymone. So Aymone is a data scientist at Vanderbilt University Medical Center and within the Data and Research Center for the All of Us research program. And she does highlight and focus on wearable device data to include Fitbit data. So she works on the data science team and helps us with our support questions, as well as helping with the front and back end processes of the curated data repository, working closely with our curation team and other teams. So today, Aymone's going to walk us through more about the Fitbit data in the All of Us research program and ways that you can use it in your own projects and how to wrangle that data. So Aymone, I will turn it over to you.
Yeah, thanks, Sam. Well, I hope it's going to be helpful for everyone. So we'll go through a section to help you understand better the structure of the Fitbit data. Then I'll talk about collecting the Fitbit data with SQL, including some things to consider. And then we'll have some queries examples in the notebook for you later. So yes, move on. Next. Thank you. So a little background of why the Fitbit data can be useful for your research. The Fitbit data basically is part of the digital health technologies, which can collect nearly continuous data that is not available in a regular EHR system. And as of 2019, there was about 1 in 5 Americans that had a smartwatch or a fitness tracker. And so this is a very rich raw data source that can be very useful for our researchers, which is why in 2020, AOU decided to introduce the Fitbit into the CDR. And we continue to grow both in data types and in quantity, and we're exploring other sources of data besides Fitbit for future releases. Next. So this is basically a high-level counts of the number of participants that we had throughout the years of the releases of Fitbit. So we started with about 8,000 participants, and we only had the data in the registered tier in 2020. And then as of the latest release, V7, we have almost double that. And then we have it available both in the control tier and the registered tier. And then we added recently the sleep summary as well. Next. So the Fitbit data, you can think of it as it has 3 main data elements. You have heart rate data, you have physical activity data, and then sleep data. Next. So each of these data categories has different granularity level. So for the heart rate, you have a daily summary and a minute level summary. The same for the physical activity, except the minute level summary is only for the step data. And then for the sleep data, you also have a daily summary and then a sleep level summary. Next. This is basically what the heart rate summary data looks like, the tables. And you've got these columns, and this is not real data, it's just fake data, but you have a unique identifier, a person ID, and then you got the date of the heart rate log, you got the zone name, and then you can have 4 possible zone name. You can have out of range, fat burn, cardio, and peak. Out of range doesn't mean no data. I know this name is confusing. It means that it's anything below fat burn, with peak being the highest heart rate possible. And then you've got minimum heart rate and maximum heart rate, and the minutes that the person spent in the heart rate zone. And then you also have the calories burned in the heart rate zone. The next table is the heart rate minute level. So if you click next, Sam, thank you, is you also have the unique person ID, and then a timestamp, which is on a minute level, and then the heart rate value for that minute. Next. The activity summary also has the unique identifier. You have the activity date, and then the activity calories, and then all the calories out, calorie BMI, which is the basal metabolic rate calories, the elevation in feet, and then the number of minutes spent in fairly or moderate activity, light activity, and so on and so forth. And then you have the number of floors, which is calculated in feet. And then the rest is pretty self-explanatory. So next. We can keep going. Thank you. The step intraday, you got a unique identifier again, and then the type stamp for that intraday activity, and then the number of steps on a minute level. Next. Next, we have the sleep data. And for the sleep data, you have, again, the unique identifier and the sleep date and whether the sleep is main sleep or not. Main sleep is basically the time that you spent, overnight, 8 hours of sleep. And then the not main sleep will be the naps that you take during the day, for example. And then you got the number of minutes spent in each of the sleep levels. And then for the sleep level, which is the next one, then you have, in addition to the person ID and the sleep date and the minutes, the main sleep, you've got the sleep level in one column, and then the timestamp, and then the duration per sleep level. Next, please. So all that I just explained will be available to you in a data dictionary with additional descriptions of the tables. I would encourage you to look at it. The data dictionary is linked in your workspace, in your notebook. You can see that. And we recently published a very useful article that gives you basically an overview of the Fitbit data elements. We're not trying to help you design your study. That's not what we're trying to do. But we're trying to give you an understanding of some things that the data dictionary doesn't explain. For example, how does Fitbit decide what is peak heart rate? It gives you a percentage there of how Fitbit defines that. What is REM sleep? What is awake? What does that mean? And we give you a link to even the raw Fitbit API, so you can go look at how Fitbit is actually getting this data and defining what each of these means. So you can decide what you need for your cohort and design your study that way. Next. Okay, now we're going to go through collecting AOU Fitbit data. Next. So AOU Fitbit data is challenging, and there are a few things to consider because it's huge. As you can see, in V7, this is the number of rows that you have per table, and you can see how step intraday in particular and heart rate minute level have so many rows and are very huge. So you need to be restrictive in your query when you query these tables, all of the tables, but especially these two tables. And if you're using the cohort, you can go next, Sam. Next. If you're using the cohort builder, you can see in the aggregation, in the query that is returned, that you have aggregations there, and that is because you just can't do select all the columns from the tables with Fitbit data. It will most likely crash. You have to use some aggregation. So our recommendations is that you do as many calculations and wrangling within the SQL query as you can. And I will show you some examples of what you can do. And then in the SQL query, again, never just select all the columns from a table, especially with Fitbit table. We want to use some conditions in the where clause to restrict the number of rows so that you don't crash your notebook. And also, Fitbit data is also long format like the rest of AU data, meaning a participant will have multiple rows of data in a table, and that it's not all mark formatted. So you will not find concept IDs or anything like this in there. Next. Okay, So if you don't know SQL, don't worry. You can get a SQL query with the cohort builder or dataset builder and run it in your Jupyter Notebook. Now, you can also write your own query if you know SQL, or you can do a combination of both. You can get the query from a dataset builder and then make some modifications. Now, when it comes to Fitbit data, it's helpful for you to have some basic understanding of SQL so you can maybe make some modifications to your data set, because the engineer cannot write every possible aggregation of Fitbit data out there. So if you know how to do that yourself, you can easily modify your query. So I will give you a very basic overview of SQL, and then we'll go through some examples of querying Fitbit data in the Researcher Workbench. So with every query, you gotta have your select and from statement. Those two are required. It won't run if you don't have either. And the where condition is optional, but you have to have it with the Fitbit. It's highly recommended because that's where you use your filtering functions. So this is just an example where we're selecting the person ID column and the minute in bed columns, and each column is separated by a comma. And then from a table, so select columns from table where condition. In the first query, we're just making sure we select only the main sleep. That is the first query. The second query, it's the count data. So we're getting the count of unique participants per zone name from the heart rate summary table. So this is very high level. And if you have questions, at the end, we'll take them. Now, let's go to the notebook and I'll show you some actual examples. Let me share my screen. Right, so this is a Python notebook, and I'm going to show you a few ways that you can query row-level data, row-level Fitbit data using some aggregation. So the first thing that you need to do in any notebook is to install your packages or import the packages, and we're going to import a few ones here. You notice this is a package that also allows you to read data from SQL into Python, just like Panda does. It's a variation of Pandas, except it's 35% faster than just Pandas when you have a really big data set. When the data set isn't that big, it doesn't make much of a difference. But if you have a big data set, and I will show you, use this instead of Pandas to read data into your Python data frame, okay? And then the next thing that we want to do is to select our dataset variable, and we include it in our query. Why? Because we need not only to give the table, but also, if you will, the address of the table in the BigQuery database, because there are a lot of organizations and a lot of data sets within BigQuery. So we need to point specifically to the place where heart rate summary is or sleep level is. And that's what this variable helps us to do. You don't have to remember this. All you need to do is to get the environment variable with this code, and it will be updated with every release and every workspace, whether you're in CT or RT. So this is just an example of counting data, as I showed you in the slide earlier. We're counting the number of persons per zone name per date. So that is a very simple query. Now the next step will be to show you how to extract row level data with limiting the number of rows. So same format, we select from table, and I'm selecting these specific columns, and in order to limit the rows, I'm just using limit, and I want to limit it by 10,000 rows. So these are a few more examples of how to do this. Here I'm selecting these columns, the date, the sleep type, the minute in bed, the minute in REM, and in the where condition, I am making sure that the minutes in REM are not null and that we're selecting the main sleep. Now, in the synthetic data, the main sleep is the values are main, and I don't remember which else is, but in the real data, it will be true or false. So in the real data, you will have to write here true. This is just because this is synthetic data. Another example is with the step intraday, which is very huge. So I only selected 3 columns and I'm limiting it by 10,000 rows. Now, as a researcher, most likely you want as much data as you can, so you may need to limit, but if you don't want to, there are ways around it where you can get all of the data for your specifications, but you need to use aggregation. So what kind of aggregation can you use? You can extract, for example, the year instead of the timestamp. You can extract the minimum and maximum date instead of the actual dates for all the rows. You can extract average values or some values and do more calculations on the values so that they come in an aggregate format. You can filter by date. You can extract data for only 1 year or data before or after a year. And you can extract data for a limited number of people. So if you have a set of people that you want, you can define this instead of the whole 15,000 people. And it's better to write multiple small queries and get multiple data frames and maybe try to combine those after some wrangling rather than trying to write like a huge data frame with multiple joins together. That's not going to be efficient. So here are some examples of what we can do. Right here, I'm extracting participant row level data from the heart rate minute level, and I'm getting the average heart rate value, and only for the year 2017. So this is an example of how to do this. Average is just AVG, and then to get the year from a timestamp or even a date, you just use in Google BigQuery, you use extract year from blah, 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 and then you give it the date that you want. And again, this kind of aggregation, you will see those when you use the cohort builder or dataset builder. Next time that you see them, you can kind of understand what's happening and maybe try to write your own query based on that. And you can, of course, always review this presentation later. Now, this next example is getting the average hours asleep. So I'm basically dividing the average minutes asleep by 60. And I'm making sure to get only main sleep. And this is going to get me all the data, but in an aggregated form per participant that I can use for more wrangling later. The third exercise here is extracting the year instead of the date or date timestamp for the step intraday. And then I am getting the total number of steps per year per person, basically. And I'm only doing it for 2 years, for 2017 and 2018. The keyword in helps you. So another way to do this would be to say where extract year from daytime equals 17, or extract year from daytime equals 2018. So to avoid multiple, like a long statement, you can just use in and then put those 2 dates, 2 years in a parenthesis. So that's an example. And if you notice, I'm just calculating how long the queries take. These took like 44 seconds. Some of them took a second. So you can add more columns if you want. It will still be faster, but just keep in mind not to be too greedy. And then this one, I'm basically getting the average hourly minutes in each of this hourly minutes, the average hours spent in each of the stages per person, instead of just, all the rows, and only for main sleep. And this took very little time to do this. Okay, keep in mind this is synthetic data. There's less data than the real data. So it might take a little more time, but it still will be very fast because I'm using aggregation here and I'm also filtering in here. Now, another thing that you can do, and I'm not sure if this completed to run, yes, is using temporary tables. Now, this is something new that I'm introducing here. I don't think I've talked about this before in the presentation, but temporary tables are very useful. So as a researcher, you cannot create or write permanent table to our data set. You don't have that access. You can see how that could be problematic if you did. And you cannot write temporary tables to the data set either. But what you can do, you can still use the power of temporary tables to perform efficient queries that otherwise would be too complex or too large because the data set would be huge. So basically, what are the benefits of temporary table? When you create a temporary table, each of them is stored as cache query results, and it's at no cost to you. Basically, it's temporarily stored in your session somewhere. Don't need to know where, but it doesn't go to actually the AV data set. And it's all done within the query. So you can create multiple smaller temporary tables and join them together within the query. So here is an example for you. And how long did this take? It took 5 minutes, which if you were to run each of these separately, it would take way longer than this. So, and I'm using the Panda and the Scope Google BigQuery versus just Pandas Google BigQuery because for a larger operation, it's faster. So I'm creating here a temporary table for anyone with a condition, an EHR condition, and that is stored somewhere temporarily. And then I'm creating a temporary heart rate table, heart rate summary table, and I'll store it somewhere as well. And then here I'm creating another heart rate table from the intraday summary table from 2017, and it's also stored somewhere. And then here I'm joining all those 3 temporary tables together, and then the results is what I'm going to get in my data frame. And I can save this in my bucket so that I don't have to rerun this every time. But this is an example of what you can do with temporary tables, especially with Fitbit data, because you can write multiple small temporary tables, even do multiple queries like this, and then you can join them together. So this is another example that this one was going to take a little longer, so I didn't have time to finish running. It actually finished, but I stopped it too early. But here I'm doing the same thing. I'm creating 3 temporary tables, one for the demographics, one for heart rate summary, and I wanted only the heart rates that were above 70. And then here I've created another one for the activity summaries. I wanted to see the people that had less than 20 minutes of very active minutes or fairly active minutes per day. And then I can join all these 3 together and get the result. So if you have not tried temporary table, even not just with Fitbit table, but with any AV data, you can try this. It's helpful. And I think that's all we have for the presentation, and I can open it up to questions. It took way less time than I thought.
Thank you, Aymone. So now this is an opportunity for you all to ask questions about the Fitbit data or wrangling the Fitbit data. So feel free to put your question in the chat or come off mute, and we'll take your question.